Hello everyone, welcome to the channel. In this video, we are going to take an essay on electricity. So let's start. The word electricity comes from a Greek word meaning ampere, because it was the Greeks many thousands of years ago who first discovered this mysterious force. They found that if a piece of ampere was wrapped with fire, it would pick up pieces of straw and other lightweight materials. Later, scientists discovered that other material would act like ampere and could be given charges of electricity. Today, such charges of electricity can be produced in a similar way by running a comb through the hair or by shuffling across a thick rug, but all this is very primitive, and before electricity could really become the servant it is today, scientists over many years have had to discover a great deal about it. They have had first of all to understand something about the smallest of all units, the atom. This is made up of minute particles called electrons, which can, given the right stimuli, move from atom to atom. Here we must remember that all these divisions of matter are very small indeed. They are so tiny that they cannot be seen even with the most powerful microscope. It is these electrons which can move from atom to atom, which form an electric current, and the scientific definition of an electric current is a stream of electrons moving through certain materials. More than 150 years ago, an Italian scientist named Volta found a way of getting an electric current. He invented an electric bell, but only a very weak current came from it, and so it wasn't of much use. It's only since Michel Faraday, a British scientist of the 19th century, invented a machine to push electrons on their way and thereby to produce a current of electricity. That electricity has become really useful. Faraday's machine was really the primitive and the simple forerunner of today's modern generators. Nowadays, we use both electric cells and generators to supply currents of electricity. A battery which we use in a portable radios, hearing aids, motor vehicles and electric toys is made up of 2 or more electric cells joined together. Such cells are made up of zinc and carbon with a moist mixture of chemicals in between. It is the action of these chemicals on the zinc which starts the flow of electrons and thus causes the electric current to begin to flow. A generator is made up of 2 magnets and coils of wire, either of which must be whirled round and round to start the electrons moving and to begin the current. Hence, generators are often driven round by large water wheels, and the electric power plants are often to be found near waterfalls and dams. Steam turbines are used to turn generators too. The electricity which is supplied to our houses, to our shops, streets and offices all come from generators, as do the currents in the big machines and factories. Thus, we are provided with lights, fans, cookers, and the modern electric appliances which we know today, from the simple electric light bulb to the most elaborate electricity-driven machine. Loads of iron can be lifted by electric machines. An X-ray picture can be taken. Silver knives and forks can be replated from electricity produced by a generator. But before ordinary people could feel the benefits of these things, scientists and electricians have had to learn a great deal about the use and control of electricity. There is much more to it than the setting up of a flow of electrons and the turning on of a switch. Circuits or paths along which the current can run must be set up, and there must be easy ways of stopping and starting it. Electricity will flow through some substances which are called good conductors more easily than others, which are called bad conductors, but both are equally important because poor conductors are used to stop electricity from flowing where it is not wanted. The circuits of electricity are made by wires, which bring the electricity from the power plants to our houses, to the switch in the wall, to the cookers, to the power points. All we have to do is to put the switch on or the plug-in. This action joins the wires in the plug or switch to the wires connected with the generator, and the circuit is made complete. It is broken when the switch is turned off or the plug removed. All this sounds very simple, as indeed do all great discoveries. But when we consider the myriad uses of electricity for all our home appliances, our television sets, our transport and telegraph systems, we should think for a moment the depth which modern civilizations owes to men like Faraday and others, who in former years wrote out the many signs we now see placed in electric lights all over the world. Electricity, your servant. So today's essay was on electricity and how it was discovered and the uses of electricity in our daily life. So please don't forget to like the video and subscribe to the channel to get more videos and essays. See you next time. Goodbye.